Section 10-3 is about radical equations. Now, first off, what a radical equation is, it's just any equation that contains variables in the radicand. So remember, radicand has to do with the square roots. So anytime you have something that might look like this, square root of x equals something over here. So maybe we said like 10 or something like that. This would be a radical equation, as long as there's a variable inside of this square root part. So if we want to solve radical equations, we isolate the radical on one side of the equation first, meaning there should be nothing else over here. You don't want something like 10 plus the square root of x minus 1 equals something, maybe like 50. We wouldn't want this because we have this over here, this extra 10 plus all of that. We want to get rid of this one first so that we just have the square root. Once we have just a square root, we would square both sides and then solve what remains. So let's see some examples of how this looks. For example 1, we need to solve 9 equals the square root of x. Well, again, our first step was always to isolate the square root. Well, this square root is already alone. Once it is alone, we just square both sides. So square this, square this. Now remember, our properties say if you square a square root, they basically cancel each other out. They go away, so we just have x over here. Now 9 squared, we know 9 times 9 is 81. So our equation now says 81 equals x, which means we've actually solved it. So this would be our solution. If 9 equals the square root of 81, or the square root of x, then x has to be 81. So let's look at example 2. We have 2 equals the square root of a plus 2. Again, we always want to isolate the radical. Now in this case, we might think, oh, it's a plus 2, so we might need to get rid of that. No, actually, because it's all underneath the square root together, our radical is alone. We just need the square root part to be alone. So at this point, we actually have the radical all by itself. So we jump to that step of squaring both sides. Now this square and the square root cancel out. So our equation now says 4, because 2 squared is 4, equals a plus 2. Now we're not quite done yet because we want a all alone. So at this point, this is where we would need to subtract 2, because we added 2 over here, and subtract 2, in which case we get our solution of 2 equals a. So this would be our final solution. Now with both of these, you can double check by plugging it in. If we plugged in 81 right here, the square root of 81 is 9. All right, that works. If we plug in 2 right here, well, 2 plus 2 is 4. Square root of 4 is 2. So it checks out. All right, let's go on to example 3 then. We have the square root of x over 7, x divided by 7. Now again, this is all under the square root together, so technically it's all one piece. So we don't need to worry about getting rid of that 7 yet. We need to get rid of the square root part first. So since there's nothing else over here, we jump right to the squaring both sides. When you square both sides, that's going to help us get rid of this square root sign. So we just have x over 7 left on this side. We have 9 squared left on this side, and 9 times 9 is, of course, 81. So now it says x divided by 7, x over 7, equals 81. Well, how do we get rid of a divided by 7 on both sides? We'd have to multiply by 7 on both sides, in which case we now have x equals 567. Now again, you can double check that, make sure it all works out. 567 in for x. 567 divided by 7 is 81. The square root of 81 is 9, so this one checks out. Example 4, things start to change a little bit. We now have all of this in our square root, but we have an extra piece over here. It's being added on to a negative 10. How would we get rid of this negative 10 from both sides? Well, we have to add 10 first to both sides of our equation. When we do that, this will cancel out, so we just have the square root of x minus 1 over here. On this side, negative 2 plus 10 becomes a positive 8. So because this was plus right here, it's saying a positive square root of x minus 1 right here equals a positive 8. Now we do have the square root alone on its side. So to get rid of it, we square both sides. Squaring this side will get rid of our square root. Those cancel out. 8 squared then is, of course, 64. So we have x minus 1 equals 64. Now, to get rid of the minus 1 on each side, so that we can have x all alone, we would add 1. When we add 1 to both sides, we get, of course, that x equals 65. So this would be our final answer. Now again, we can double check, plug it back in. 65 minus 1 is 64. Square root of 64 is 8. Negative 10 plus 8 is going to be negative 2. Example 5. Solve negative 56 equals negative 8 times the square root of n plus 1. Now remember, whenever these are written right next to each other, like this negative 8 square roots of n plus 1, this means they're being multiplied. So to get rid of it on both sides, we would divide by negative 8. Divide by negative 8. Again, we need this square root piece to be all alone. So we can't have this whole thing being added or subtracted from anything. We can't have this whole thing being multiplied or divided. We have to have just the square root piece. So dividing by this negative 8 is going to cancel that out. Negative 56 divided by negative 8 is then positive 7. Now, for these equations, we're always going to treat our square roots as positive. Okay, we can only get positive answers for these ones. So when we say 7 equals the square root of this, that's allowed because 7 is positive. Now, to get rid of this square root on both sides, we square both sides. This square and this square root cancel out. 7 squared is, of course, 49. So we get 49 equals n plus 1. We get n completely alone. We subtract 1 from both sides, which, of course, leaves us with 48 equals n. And that would be our final answer. Of course, we can double check it. Plug 48 in up here. 48 plus 1 is 49. Square root to 49. Again, we treat it always as a positive, so we'd say positive 7. Positive 7 times negative 8 is going to be negative 56. Example 6 then. We have the square root of 9p minus 2. This is all together. This is the square root part. Plus 1 equals 5. So the part we need to get rid of first before we can square both sides is this plus 1. So we have to subtract 1 from both sides, which means then we now have square root of 9p minus 2. It looks like we just rewrote it all. 9p minus 2 plus 1 equals 5. Subtract the 1 on both sides, and we now have 9p minus 2 equals 4. Now from here, this is where we're going to square both sides. Squared and squared. Square root cancels out with the square. So now we have 9p minus 2 equals 16, because 4 squared is 16. Now we just solve it like a regular equation. Add 2 to both sides. 16 plus 2 is 18. Now we have 9p equals 18. So we'd have to divide each side by 9. This is going to cancel out. I guess this one canceled out too. Which means we're left with p equals 2. Again, we can double check our answer of p equals 2 by plugging it back in here. 9 times 2 would be 18. 18 minus 2 would be 16. The square root of 16 is 4. Positive 4, we'll treat it always as a positive. Positive 4 plus 1 equals 5. Now I'm saying that we have to treat it like a positive because technically, if you have the square root of 16, there's two answers, positive and negative 4. Right? Because negative 4 times negative 4 is 16, but also positive 4 times positive 4 is 16. But when we are working with equations, you always treat it as though it was a positive. All right, example 7, we have square roots on both sides. So we have the square root of b plus 10 equals the square root of negative 4 minus b. So a note for this one, if both sides contain the radical symbol, then just square both sides and solve the equation that remains. So this one is actually pretty darn easy. If we square both sides, that means it cancels the square root on both sides, which means we're just left with the equation b plus 10 equals negative 4 minus b. So it makes it nice and easy. We can add b to both sides. Now if it helps, think of this one as 1b. This is a minus 1b. So we're adding 1b onto both sides, which means then after these cancel out, on the left side we would now have 2b. 1b plus another 1b is 2b. So 2b plus 10 equals negative 4. To get rid of that positive 10, we subtract 10 from both sides. Now again, that's going to cancel out. So we are left with 2b equals negative 14. Now to get b all alone, we would need to divide by 2. When we divide both sides by 2, this 2 is going to cancel out. And we now have b equals negative 7. Now we always need to double check our answers, check for extraneous solutions by plugging it back in. If for some reason we accidentally get underneath our square root, so say our square root came out to like a negative 16. Now this answer is not negative 4. We can't have the square root of a negative. This doesn't work. Okay, so when we plug in this negative 7 into both sides of our equation, they had better both be positive underneath our square root. So when we plug it in underneath this square root, we would get the square root of, well, negative 7 plus 10 is going to be positive 3. Okay, so that one worked out. It is positive. It's okay. On the other side, we'd get square root of negative 4 minus a negative 7. Now, when you minus a negative, it actually becomes like positive. It's like it's adding. So negative 4 add 7 becomes positive 3. Since these are both positive, they're both 3, and they say negative or square root of 3 equals the square root of 3, that is a true statement. So this checks out, and this, b equals negative 7, is our actual answer. And that'll be it for our third video.